talking about some more advanced atomic structure. All right. So you might have learned previously the Bohr's model, where you have rings of electrons around a central nucleus of an atom, right? And it follows the 2, 8, 8, and 8, and so on and so forth for however many electrons you have. But this is actually a somewhat inaccurate model. So today we're going to be talking about how to the more advanced and accurate version. All right, so we still have our nucleus. Our nucleus is still made of our protons, which determines the element, and our neutrons, which determines the isotope. Now, here's the thing. Our electrons, they're actually arranged in things, well, they're still the shells. All right, we call these the rings the shells. But they're actually arranged in something called orbitals, and there's 4 different types of orbitals: S, P, D, and F. And there's some really great 3D visualizations of what these orbitals look like. But all you have to know is that the first shell only has the S shell, and there's only one of these shells. And for each orbital can always hold 2 electrons. And you also might be thinking here, if 2 electrons are both negatively charged and they don't want to be next to each other, how come they're always in pairs? Well, this is going a bit into quantum reactions, but there's something called the Pauli exclusion principle, where basically one of these electrons has a spin state called up, and the other one has to be down. So they actually like being, well, they can handle being in pairs, and they can handle being in just being one, but they absolutely hate, and they just don't exist in trios and stuff like that. But going back to our orbitals, right? So each orbital, we got 2 electrons in, and there's 1 s orbital in the first shell, so 1s, and that makes sense with what we know so far, because 1 s orbital, that means it can hold 2 electrons. So the first shell, it can hold 2 electrons. That follows what we know so far. The second shell, it has 1 s orbital plus 3 p orbitals. So if we do some math here, 1 plus 3 is 4. So we have 4 orbitals in total, 4 orbitals and 2 electrons each. So second shell can hold 8 electrons. And third shell, following this pattern that we've seen so far, we have 1 s shell, 3 p shells, and 5 d shells. So adding that up, we have 9 orbitals in total, 9 orbitals. So it can hold 18 electrons. Now notice I'm saying it can hold 18 electrons, because in real life, right, you can think of these electrons as being people. They don't like being too close to each other. So instead of fully filling up one shell, they sometimes might go to another new shell first. So for example, if the third shell, so we have our single s, we notate this as 3s. Okay, so since it's the third shell and our s orbital, because remember, when I said that there were one s orbital, 3 p orbitals, and 5 d orbitals, that's in addition, like that's only within that shell. The previous ones, you can basically only just remember each shell as having their own set number of orbitals. and we write a little exponent here to tell us how many electrons are stored in there. So 3s, 3s2 is 3p2. What happens here, sorry, I should write p6. What happens here, instead of going to the next the next d orbital, what actually happens is that the electrons go to the next s orbital. And this is something called Aufbau's principle. So if we draw our shells like this, so our first shell in our orbitals like this, second shell like this, third as such, fourth like this. Now this is obviously a bit of a simplification because it doesn't actually tell you how many of each orbital there is, but that isn't the important part. So what actually happens here, so the electrons will fill in this order. So first s shell, second s shell, and then the p shell, and then the s shell, and then the third p shell, but it'll actually go to the fourth s shell before going to the d shell of the third one. So again, you can think of it as like people in a restaurant. Sometimes it's easier to open up a new room than to try and squeeze more chairs and tables into the old room. And they follow this sort of zigzag order where it will, this way, the electrons will always follow the path of least resistance, and they will always just go to the shell that they want to. And that's about it for part 1 of advanced atomic structure. Thanks for listening, and leave any questions you have in the comments.